Hello again. Let us now go ahead and write the program for implementing the circular queue operations. I'll just copy the previously written queue program for the FIFO queue. You must remember that. We added menu to that program. A main was written there. And we'll just copy that and we'll change the init queue, enqueue, and dequeue operations. These are the three operations that we need to change. The rest of the programs are going to remain same. So I'm just copying this file and I will paste it here in the sir_queue.c. I have created this new file. Okay, now let us change the functions according to the circular queue algorithms. In the init queue method, we need to initialize both the front and rear at size -1. So let me do that. Now for enqueue, we need to check whether the next element of the rear is front in a circular fashion. Okay, so it should be rear +1. I think you can follow me at line number 22. Rear +1 mod size. That must be equals to front in order to satisfy the overflow condition. Okay, so here we go. So if the QP_arrow rear +1 mod size is QP_arrow front, then obviously it satisfies the overflow condition and will return from this enqueue method after printing the overflow message. Otherwise, we need to move the rear to the next element first, and then we need to assign the value at the rear index. Okay, let us now move the rear to the next. Let me copy this portion. So QP_arrow rear equals QP_arrow rear +1% size. That will move the rear to the next location. Now we need to assign the value v at the rear index of the item array. So this is the statement that will do that, and we are done writing the enqueue operation for the circular queue. For dequeue, if the rear and the front are at same position, then it's underflow, and it's the same thing that we did earlier. We are returning an absurd value -9999, and otherwise we need to move the front to the next location in a circular way. And so for that, QP_arrow front equals QP_arrow front +1 mod size. That will move the front to the next location. And once the front is onto the next index, then we can pick up the value from that index. So we are picking up the value from the current position of the front, and we are assigning that to the variable v, and we are returning v to the caller. So that's it. Now let me see everything there. Yeah, there looks good. We have a size 5 there for this queue, and I'll test it. Okay, let me just go ahead now and compile and test this program, and you'll see that we will overcome the issue that we had with the earlier implementation. Okay, let's move ahead and see. Here you go. Let me just compile the program first. GCC and the file name, that's cir_queue.c. Okay, that gets compiled successfully. Let me run that. The menu is visible. Let me do the enqueue first. Now 1, 10 is inserted into the queue. Let me do the enqueue once more. 20, one more time, 30, and for the final time 40. Now if I go ahead and try to enqueue one more time, it's going to be overflow. You see that? Now let me delete one. Now 10 has been deleted. I'm deleting another one. 20 is deleted. That is first in, first out. That's okay. Now if I try to do the enqueue once more, then it will be taken, right? It's unlike the previous situation where once the overflow happened, then it will be always overflow, right? Now let me just go ahead and give option 1, and I'm giving 100. Okay, that is it. 100 has been inserted into the queue. I can insert one more because we deleted 2 elements there. So now if I try to insert one more element there, it's going to be overflow. So I can go ahead and delete that. Yeah, you can see that it's working fine. One more deletion will actually show underflow. That it is. So that's how it is working. So let us wrap this section of circular queue now. And I hope that you have enjoyed the idea of circular queue with me. In the next section, I'm going to introduce the conception of double-ended queue, where we can insert and delete on both the end of the queue.